Okay, so now I'm going to take you back to the special angles. You will therefore realize that what you've learned up to this point is connected to all that you did from the start of this topic. So I'm just going to start small, and I'm also going to challenge you to try and remember those triangles for the special angles, because in an exam you will be expected to know them by heart. They will not be given to you as part of the formula sheet. So that means you must at all the times know the special angles. Suppose you are given sine of 60 degrees. So the statement will therefore say, use the special angle diagrams to calculate the following. And then you will be given that sine 60 degrees. So in this case, obviously you need to have that diagram of the special angle and check to say, with reference to angle 60, what is therefore the ratio for sine? The ratio for sine, we know it is opposite over hypotenuse. So what is opposite 60 degrees? I think that is square root of 3. Then what is hypotenuse? It will therefore be 2, and that should be the end of it. Not that much complicated. It's a straightforward question. So what if you are given, let's just say, tan of 45 degrees? This one, it will definitely be tan. We know it is opposite over adjacent. With regards to the special angle for tan, we know that the opposite is is it not 1? Definitely it is supposed to be 1. What about adjacent? It is also 1. It therefore means opposite over adjacent, it is equals to 1, because 1 over 1 it's equals to 1. So even if we had to do one where the special angle is 60 degrees, I'm pretty much sure that you will therefore be in a position where you are able to work it out. So now, for the angles being 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, let's have a look at those angles. So here, let's see, we can draw our Cartesian plane, and then let's say from an angle of 0 degrees, we will go to 90, go to that, go to 270, and then end at 360 degrees. We're just trying to figure out what those angles are. So I'm just going to be straightforward and say here where you are having your angle being 90 degrees, they say that point there, the coordinates of that point there, we are going to be having 0 and 2. And then at that point there, where the angle is 180 degrees, that's where we are having that point there. So for this purpose, they are referring it to as point G. I'm actually working it in the opposite direction, but that means B is on the other side. Then we are having -2 and 0 there, and then that point there. So it's like I'm actually drawing this where it's 270, the angle is 270. I'm actually redrawing this straight from the textbook. This is something that you might be using in case if the angle is given to you, for example, as maybe 90, 180, 270, and 360. Sometimes even 0. So that point there, it is point E where we are having 2 and 0. So I think it is straightforward, which is that point. So that means the coordinates, it is just 2, 2, 2. It depends on the quadrant where that lies. You can see the one that lies along the x-axis on the left hand side, it will definitely be negative 2. On the other side will be positive 2. Then the ones along the vertical line, the upper side will be positive 2, and then the lower side will be negative 2. So now with regards to those other angles, they started with this one and say from that angle maybe going there's like they are saying from angle 0 going to that line there, that one, it is angle 60. And then they did another one there saying from there to there, that one, it is the one for 45. And lastly, they did the one for 30 degrees. These ones you know about them because these are those what is it, the 30, 45 and 60 degree special angles. So this would be that right angled triangle for the 30 degrees, and this would be that one for 45. This one would be that one for 60. So I just don't want to confuse you that much with regards to those ones. So let's say maybe you are given what? Let me just think of an example. Let's say we are given cos of 90 degrees. So cos of 90 degrees, how would we therefore work it out? We know that cos it is actually x over r. Yes, it is x over r. So now the question that we are having is to say what will be the x value there. The x value where the angle is 90, we therefore focus on point A. The x value is 0. So that means with the x value being what is it, being 0, whatever the r value that we are having, of which that r value it is 2. Why am I saying it is 2? Remember, r, it is the radius. So if we already have that distance there being 2, because obviously for the special angle we have that angle being 30 there, and you know what that side is, you know what that side is. So that means if this is 2, that means even that it should be 2, that it should be 2, that it should be 2. So that is why even that point there it is 2, that one it is 2, that one it is 2. It is the radius along that circle where we are taking into consideration the special angles of 30 degrees, the one for 45 degrees, and that other one for what is it, 45 degrees. So now let's say here we substitute that 2. What will the answer be? I think if you say 0 and you divide it by 2, it will definitely be 0. So that's why when you say cos 90 degrees, it gives you 0. Okay, so now what if, what else? Let's say you are given a sine of 270 degrees. What will that one be? So again, we look at what the ratio for sine is. The ratio for sine is sino opposite over r. So what is opposite there? When, let's see, just hold on. Opposite obviously being what? Opposite being y. Oh yes. Now I've just remembered that we will therefore have to write it as x, y, and r, not o, because it even looks like I'm saying 0 there. So what is opposite? Opposite is y, in this case, over r. Then you look at that diagram again. You say for 270, what is your y? Your y, it is -2. Obviously your r is 2. So that means it's like we are talking about -2 over 2. So -2 over 2, it is definitely equals to -1. Yes, that's how you would work it out. So I'm sure that you might be confused, especially if you do not know those special angles. Very quickly I will draw them again, but just make sure that you draw them on your paper, and then as I explain, you can refer to them, because without those special angles you are in a big trouble. Okay, maybe let me start with this one of what? This one of okay, this one of, let's say, 30 degrees, whereby the hypotenuse, it is 2, hypotenuse or the radius, it is 2, and then that is 1, and that is square root of 3. And then we also have that one of 45 degrees. The one for 45 degrees, we have one there, we have one there, and then we have that hypotenuse there being not that. I don't know why I'm saying that, but that. Just hold on. Just hold on. Let me quickly verify something. Let's see. Nope, not that. That. And then we say 45. Yes, okay, then it's fine. I was just verifying with a calculator there that I drew it correctly. There is a way in which you can verify, but I just don't want you to know it, because you will end up using calculations or calculator where it's not necessary, or where you are not supposed to. So let's say there you are having 60 degrees, and then again this one, it is the same as that one of 30 degrees, where you have that, that, and that. Yes, so where that 2 is coming from, it is that one for the radius, it is that one for the radius, where I was explaining to say, for when we have an angle of 30 degrees, the radius is that, and then for when we have that one of a 60 degrees, what is it? Our radius there, it is 2. And again, let's see, according to this diagram, they do confirm to say even when the angle is 45, that radius should be 2. So it doesn't matter what the angle is, the radius will always be that. What may differ, it could be the coordinates. So that means those coordinates there will be something else, something else, something else, something else. I just don't want to confuse you with that information, but I think for now what I wanted to do, it was just to give you that information regarding the special angles and that diagram. So now I hope you drew that diagram because I'm now going to do a few more examples and I will refer to that diagram. Let's just say for some reason you are given cos squared of 150 degrees. Okay, so just remember that if an angle is bigger, we want to reduce it before we can do much. So how are we going to reduce it? That squared of that angle. Just be careful and be aware that it simply means two of the same thing. So that means you will be having your cos of 150. That angle of 150 is definitely 180 degrees, where you do what? You minus 30 degrees. Yes, I've done it correctly. So I did those corners because I wanted to put a squared there. I am going to have this bracket and I knew I was going to have those brackets. That's why I started with the one for the corners. So now I will just deal decisively with this thing inside. What is this thing inside? Cos is negative in this quadrant. That's why I'll write it as negative cos of what? Of 30 degrees, whereby now it wasn't even necessary to do that one of the things. Okay, so now it's fine. What do? I still have that negative cos of 30 degrees. Cos is the ratio of cos adjacent over hypotenuse. Yes, you just need to remember the squared. So it doesn't matter whether you use x or y, it just depends on whether you're referring to the diagram or the special angles. So that means for the diagrams being the 0, 90, 180, 270 and 360, I will use the x and y and r. But if I'm referring to the special angles for the 30, 45 and 60, I would refer to them as adjacent, opposite and hypotenuse. Yes, okay, then it's fine. Let's substitute. What is the adjacent from the special angles? Adjacent, while the angle is 30 degrees, is definitely that square root of 3 and then over 2. Just don't forget that negative. You will come far with that negative, very far. Okay, so now I'm pretty much sure that you will agree with me to say that squared, it simply means two of exactly the same thing. So now it's like you are given something where you need to apply the laws of exponents. That's why I had to teach you through the laws of exponents, because I knew that at some point we're going to have this. That definitely cancels with that, because now this is directly multiplying that with that. And you know by now we did the SATs. We said with the SATs, if you're multiplying a square root and a square root, it ends up being square root of 3 multiplying that 3. What will that be? It will be 3 times 3 being 9 over that times that being 4. Obviously, we do know very well that square root of 9 is 3. So that means it ends up being 3 over 4. Remember, they will say without using a calculator. So all these things that you are doing, it is without the use of a calculator. So if you just punch that on your calculator and then you write that answer, just know that you are in a big trouble, because all of it is wrong. You have to show those calculations. Let's maybe do another one, being example B, where let's say we are having a tan of negative, let's say 300 degrees, where we multiply it by sine of 600 degrees. An interesting problem there. Where are we going to start? If you remember, we will say this automatically falls in which quadrant? In the fourth quadrant. And in the fourth quadrant, we do know very well that tan is what? Tan is negative. So that means it will therefore have to be negative tan 300. Let's not waste time and say 300. It is the same as 360 degrees, where you minus 60 degrees. I'm closing the bracket for this. I will close again for that. Looks like I'm going to run out of space. Can I just remove this one? Maybe not, just in case. Let me just leave it there. It's fine. And then now multiplying this one of what is it? 600. I'm not sure if you remember, but we said we can just rewrite it as what? I think this one. It will end up being, you can say 300, you minus it by 360. If you get a value which is less than 360, then that's when you say it is the same as 240 plus that k times 360. So the k refers to how many 360s? Just one. So I hope you now remember to say this will therefore fall away on the next step. Where now you can see this thing, it falls in which quadrant? It falls in quadrant 4. And in the fourth quadrant, tan is negative. So that means you have this negative that you had, and then you still have this one of negative tan 60 degrees multiplied by, now since this one falls away, you have sine of 240. But let's just take a shortcut then say 240 is the same as what? 180 degrees. That you plus it with what? I think 60. Yes, if you plus it with 60 degrees, it will give you that. So that negative and that negative will make it positive. So that means you have tan of 60 degrees. I hope you agree with me on that one, which is multiplying, let's see, sine of where? In the second quadrant, and in the second, not second, but third, in quadrant 3. I just need to do this cast diagram will tell me. Yes, in quadrant 3, sine is what? Sine is negative. That's why I'm having a negative sine of 60 degrees. So now it's almost done, because all that I need to do is to remember that tan is opposite over adjacent. So where the reference angle is 60, opposite will be square root of 3, and then adjacent will be 1. And then where angle is 60, see, no, opposite over hypotenuse. Remember this negative, the opposite will be square root of 3 over see, no, opposite over see, no, hypotenuse. Yes, then that will be that. And it looks like I'm running out of space there. Let me see if I can zoom in and squeeze in that. It looks like we still have square root of 3 multiplying square root of 3, where 3 times 3 is 9, then square root of 9 is 3. But remember, you still have that negative there. That's why you will have to put it there, and then this one multiplying with that 2, it becomes a 2. So it's like you end up having negative 3 over 2, and you leave it there. So that would be the end of it. I'm just curious to know if I'm having space. Then just use that space there. So you will realize that it doesn't matter whether you are given a problem being a fraction or not. Whichever way it is given to you, you can just work it out applying the same knowledge. I don't know why, but it is now difficult for me to write. I think my phone is hot. Let's say negative. It's supposed to be 200 there. Yes. Let me just write slowly. 200 degrees over here, let's say sine of 290 degrees, not 270 but 290 degrees. I hope that, let me just redo it and say yes, 290 degrees. This is what I wanted to do. So without me having to work it out, I will just explain to you in terms of what your first step is. Obviously, cos 200, it falls in which quadrant? For it to be that negative, it means it falls in the fourth quadrant. Remember, it is a negative angle. We said we always assume it to fall in the fourth quadrant. In the fourth quadrant, it means cos is positive. Then it means you have cos 200 over 290 in the third quadrant, fourth quadrant. Then it's sine of 360 minus 70. Yes, 360 minus 70. Okay, then it means you have cos 200 at the top, which you can rewrite as, let's see if it will allow me to write cos of 180 degrees. That can be added to what? You can add it to 20 degrees. Yes, and then this is being divided by, if you remember, this is therefore sine of what is it? I said 360 degrees, where we minus 70. Things are now interesting. We have 20 and we have 70 there. Okay, so let's see. So just don't take these shortcuts that I'm taking, because for me, I see this thing is making it difficult for me to write. That's why some steps I'll just explain. But most importantly, you will realize that cos 180 plus falls in which quadrant? Cos 180 plus falls in quadrant number 3. And in that quadrant, cos is negative. So that means you will have that negative cos 20. And then sine into 360 minus quadrant 4. And in quadrant 4, sine is negative. That's why I'm writing that negative, there. Already that negative cancels with that. And then now you can easily say I'm having cos of 20 degrees. So what you can do, it is to change this sign and just write it as sine of 90 degrees, where you minus 70. Remember, we manipulated some things. We still manipulate this one. How are you going to know that it is time to manipulate? Always when you have different angles, check if you can take this angle, maybe not that one. If you can take this angle and plus it with that one, and they give you something like 90, then you know that it is time to manipulate. Whereby you will say 90 minus that, just so that the angles are the same. You will see as I work it out. So at the top, you still have that cos of 20 degrees. What did we say about 90 minus? In the first quadrant, and because it's 90, it does what? It changes to cos. So now it takes that angle of 20 degrees. Okay, I just noticed it's not supposed to be 70 there, but it is supposed to be 20, because what I was doing, it was just to rewrite this angle 70 in this format. I believe you noticed and got shocked a bit there. So I'm also human, honorable member. I also make mistakes. The nice thing is that for me, I'm able to detect if I made a mistake or not, because I can be able to somehow verify my answer. I can be able to, have an expectation to say this is the kind of an answer that I'm expecting. So you see now there, it's like I had 70 and I would realize that I can't go back to 70 because I wanted to change that 70 to 20. That's why I noticed something is wrong, and that's how I knew that actually there it's supposed to be 20, so that this cancels with that, and then we end up having 1. So which means if on your calculator you had to punch all of that, it has to give you 1. So that means whatever that you do, all of that, it has to just take you, it has to take you to 1. If it doesn't take you to 1, then you know that something went wrong. Something somewhere went wrong. Let me just add a blank page there and see if I can guide you through this last complicated one. Not that it's complicated. This thing is what might not be able to write it nicely, but let's see. Let's say we are having cos of 180 degrees, that is being multiplied by, let's say, sine of 225 degrees, that is being multiplied by, let's say, cos of 180 degrees, whole of that, maybe let's divide it by sine of 170 degrees, that is being multiplied by tan of 135 degrees. Okay, it looks like it was jamming, maybe because there was too much information on that page. Okay, I'll monitor that. Okay, so what can we do? I think cos of 180 degrees, this is where we can refer to that diagram. We just need to remember that cos, it is the ratio of adjacent over cosine hypotenuse. But because it is the angle of 180 degrees, I will need to refer to that diagram. You remember that diagram? Then I will no longer have to say adjacent over hypotenuse, but I will need to say cosine sx over r. And for 180, we did notice that x, it is -2. What is r? Our r is 2. Okay, this is being multiplied by sine of 225. Sine of 225, I think this one, it should be, let's see, 180 degrees. Yes, I think 180 degrees, that we need to plus it by what? By 45. Yes. See. So now what else are we having? Cos 80. What do we do with cos 80? We just write it as it is, because cos 80 degrees already is reduced. And we are just trying to simplify whatever that can be simplified and then reducing what can be reduced. So those that are already reduced, we just leave them. I think this one, since it falls in quadrant 2, we can just easily say that, and then we just minus it by 10 degrees. That's it. This one of tan 1, 2, 3, which quadrant? I think it goes to the quadrant number 2. Then in quadrant number 2, we can just say 180 degrees. We will minus it by what? Definitely 45 degrees for us to get 135. I think we are getting somewhere. So definitely this first thing will give us negative 1. Let me just put it inside the brackets because it's a negative. And then this one falls in which quadrant? Quadrant number 3. Whereby in quadrant number 3, sine is what? Sine is negative. That means you have negative sine 45 degrees. This one, you can just write it as it is. I will show you what's going to happen to that one. I'm pretty much sure that you can already see what's going to happen, because now we are having sine of 180 minus second quadrant. Sine is positive, and then it's sine 10. So you see now we have two different angles, two different acute angles. Check. If you say 10 plus 18 gives you 90, then manipulation is going to be required. Tan 180 minus definitely second quadrant, whereby tan in that quadrant is negative. Then you have that. I think we are getting somewhere. So now let's check. So you see, already I think you would agree with me to say, without me having to waste much of our precious time, that will cancel with that, because when you change the cos 80 to that sine 10, you will use cos into 90 minus 10, and cos into minus 10, cos in the first quadrant is positive, and then because it's 90 it changes to sine, then it becomes sine 10. That's why those two cancel. Do it, don't take a shortcut on that one. And then again, I think this negative will definitely cancel with that negative, and then you end up having what? I think at the top you end up having sine 45 degrees. What is the ratio for sine? Since it's 45, you will therefore say opposite over adjacent. So opposite, you may find that it is 1, and then opposite over hypotenuse, I meant to say. If I said adjacent, just to be hypotenuse. Then you divide this by tan 45, that one. Okay, apologies on that one. It's supposed to be positive because that negative there cancelled with that one. And then for tan, it's negative 1 over 1, because opposite over adjacent, where the angle is 45, it is just that. So it looks like that one cancels with that one, but you still have that negative there. Then it ends up being negative 1 over square root of 2. So according to SATS, we don't want the square root at the bottom. The moment you have a square root at the bottom, you will always multiply by that same square root by the ratio. So that means you will say square root of 2 over square root of 2. So if it was at the bottom square root of million, you are going to multiply that fraction by square root of million over square root of million. Whatever the square root is, you multiply by it. So if you had 7 there, you just ignore that 7. You just multiply by that square root. The reason why you are allowed to do that is because this same thing over this same thing is the same as 1. So it's like you're multiplying this thing by 1. It doesn't change. That's why you are allowed to do that. So when you multiply it, this square root multiplies that one there. So that means if it was 4 there, it was going to be 4 multiplying with that square root. So because it's multiplying with 1, it's invisible 1 square root of 2. And then if you're multiplying the square root and the square root, if those things are the same, it will just be that. Why? Because it's 2 times 2, which is 4. Square root of 4 is 2. That's why it ends up being that. So most importantly, you still need to remember that negative. So that means this thing, it ends up as negative that over that. So let's see. That means if you punch this original problem on your calculator, when you say it's equals to, you must expect that answer that I got there. If you don't get that one, then it means you are in a big trouble. I think I've covered enough, honorable member. I think I've covered enough. So what I can do now, it is to give you some problems to deal with. Yes, I think we are in a position where I can give you some things to deal with. Okay.